Okay, we should be live. Let's put today's challenge into the chat. Here we go, and let's pin this as well. And then move this out of the way. Okay, let's see. I have limited time today as before, so it's about an hour and a half, max 2, depending on how long deliveries come, etc. So I have to try to be fast today and maybe pick it up later tonight. So let's start right away. Day 17, Pyroclastic Flow. Your handheld device has located an alternative exit from the cave for you and the elephants. The ground is rumbling almost continuously now, but the strange valves bought you some time. It's definitely getting warmer in here though. The tunnels eventually open in a very tall, narrow chamber. Large, oddly shaped rocks are falling into the chamber from above, presumably due to all the rumbling. If you can't work out where the rocks will fall next, you might be crushed. The 5 types of rocks have the following peculiar shapes, where hash is a rock and dot is an empty space. Okay? 1, 2, 3, 4, 5. Okay. Are we doing Tetris? Let's see. The rocks fall in the order shown above. First the minus shape, then the plus shape. And so on. Wait, the minus and then the plus. Ah, okay. They're talking about the actual shape here. Okay. Sure. And so on. Once the end of the list is reached, the same order repeats. The minus shape falls 6, 7, 11, etc. The rocks don't spin, but they do get pushed around by jets of hot gas coming out of the walls themselves. A quick scan reveals the effect the jets of hot gas will have on the rocks as they fall, your puzzle input. For example, suppose this was the jet pattern for our cave. Okay, in jet patterns, that means left, the other one means right. The pattern above means that the jets will push a falling rock right, then right, then right, then left, then left, then right, etc. If the end of the list is reached, it repeats it, it wraps around, okay. The tall vertical chamber is exactly 7 units wide. Okay, we put 7 wide. And let's also test moves like that. Each rock appears so that its left edge is 2 units away from the left wall and its bottom is 3 above the highest rock in the room. Okay. So that is good to know. Left plus 2 to bottom plus 3 on the highest. Okay. Also, it will actually be minus in this case because up is minus for me. After a rock appears, it alternates between being pushed by a jet of hot gas 1 unit in the direction indicated by the next symbol in the jet pattern and then falling 1 unit down. Okay, so it alternates moving and going down. If any movement would cause any part of the rock to move into the walls, floor or a stopped rock, the movement instead does not occur. So does that mean that it doesn't do this and the index doesn't move? Let's see. If a downward movement would cause a falling rock to move into the floor or an already falling rock, the falling rock stops where it is, having landed on something, and a new rock immediately begins falling. Drawing falling rocks with an and stopped rocks with a hash. The jet patterns in the example above manifest as follows. Right falls right, push right but nothing happens, push right, nothing happens. Okay, push left. Okay, so the index does move forward, it just doesn't actually move it. Rock falls 1 unit, causing it to come to a rest. Okay. A new rock begins falling, jet of gas, yeah, okay. Sure. The moment each of the next few rocks begin falling, you would see this. Wait, let me go back to the where it becomes rested. A new rock begins falling. Okay, so but it just spawns there and then it moves. Okay. Yes. To prove to the elephants, your simulation is accurate. They want to know how tall the tower will get after 2022 rocks have stopped, but before the 2023 rock begins falling. In this example, the tower of rocks will be that tall. How high after 22? Okay, example this. Okay, get your puzzle input. Okay, and I need to have these shapes here. Did I have that in the input? No. Okay, that's a lot. Okay, shapes. Okay, so let's start coding this, and I'll move this to the side like that. Let's copy day 0 into day 1, day 17 in this case. Let's rename this. Let's set a base value of 17. Let me make sure that my screen isn't too wide. Let's put it here. Is the bottom okay? Probably need to drag that up a bit. Okay, so now it's fully into screen, and let's push it to 150% zoom as I always do. Okay. Dun, dun, dun. So we first need to actually build those shapes. So I'm just putting it off to the side here so that I can see it. Let's avoid do best. And that means input is this. Split. No, it's basically do char array, select x. X is, and then we do basically we do this dot to array. So we do move list is this. Okay. So basically it tells us how much we need to change the x-axis, which is fine. Then we do var shapes is new list. And it's a list of int x, int y. Okay, so we do new here, like this, and let's build up these shapes here. So the first one is 0, 0, then it's 1, 0, 2, 0, 3, 0. So this is the line. Just declare them in line like this. Okay. Because these are all like relative positions based, like positions based off of a relative starting point. So then we get this one. And this one means 1, 0, then 0, 1, 1, 1, and 2, 1, and then we have, let me just map it out here so that you can see it visually actually, and then we have 1, 2. Right, so you can see the shape here forming as well. And I'm not looking forward to having any sort of rotational stuff to this added, so I'm really curious to see what they will do for part 2, but I'm trying not to worry about it here and just make sure that I can at least finish part 1 in the given time. That would be sweet. So now we have 2, 0, 2, 1, and then we have 0, 2, 0, 1, 2, and 2, 2. Let me also format this like this. Oh. Okay, just like this, so you can see the shape. And then last, oh no, this isn't lastly, this is a 4 line here. Part 1 was easy, part 2 is a little harder. Okay. Good morning, Luke, and good morning, Undergame. Oh dear God, this day is so hard. I dropped on day 10. This is too much for me. Yeah, there have been a few difficult ones, like the ones from yesterday, but I had a lot of fun doing that. But I still need to change my part 2, but I don't have time for that right now. I might do that tonight, tomorrow, whatever. Let's just knock this out now because I'm under a lot of time constraints and I want to make sure that I finish this. It's actually just 4 here. So this is 0, 0. Actually, it's, and this one is 1, 2, 3. Hi Nick, I'm sporting at the moment, so sound off and watching between the set. Okay, thank you, Luke. I can just go into chat and say thanks for the support. Good luck on the workout. Okay, so these are the shapes. Oh, we have a final one actually. So the final shape is a square. Like this. So it's 0, 1, 1, 0, 0, 1, 1, 1. Okay, so this is our last shape. So that's at least something. So we have our shapes. And I can just move that up here so that it's global to the shapes. Okay. So now int block last block is 22. Const int start of set is 2, -3. Okay. It does not like that. Okay, Jesus. Static read only. That's also fine. So that's our start offset. Const int width is 7. Area width is 7. Okay. So now we do int move index is 0. Int yeah, and we can just do that and just that is fine. And we do also block index is 0. Okay. So we do while block index smaller than do while block. Okay. Block is shapes block index shapes count. Let's cache that as well. So we do static read-only int shape count is shapes count. Okay, let's do static date 17. Let's do that. Static read-only shape count, and then we do the same here. So we do shapes like this. So we have a static constructor here that takes care of all that BS. And then we do here. Okay. So now we do int highest index is 0 because that will be the floor. So then we do also a int x, int y block pos. So we do block pos is highest index plus, no, it's actually this start, no, what was it called, offset, start offset dot x. And then we have highest index plus start offset dot y. Okay. And it actually needs to be relative to the lowest. So this will also be minus block dot length. Let me just these shapes becomes int width, no, here. So we do int width, int height, and we call this the points. We do it like this. Yes, I know you don't like this. Let's alter this. So now we can do 4,1, that. Right? Yes, okay. So let's fix this quickly and make sure that the numbers are right when I finish this. There's some metadata about the shape that makes my life easier. So this is 3 width, 3 height. This one is also 3,3. And this one is 1,4. And this one is 2 by 2. Okay. So now I can do minus block dot height. Okay. Good. So now we do we also need to have a let me think, because we need to check each level, and I think the most important to know is the y-axis, so that we can check everything that's on a y-axis. So we have our dictionary of, this is the y-axis, and then we have a hash set int grid is new blah, var grid is new this, and we can actually do grid.add 0, comma new this, and then we do I really want to range things. Var floor is this, for int I is 0, I smaller than I is smaller than, let me see, width, area width, increment I, and we do floor add I. This sets up the I, and then we have floor here. Okay, and basically this will, once we cement something in, for each bottom area we can check if we need to test anything yet. Boom, 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 boom. So let me see. Block pos. We have int y block bottom. No. Yes. Did I write those both? Yeah. Okay. Block y like this. Okay. Y plus block height -1. Oh yeah, that's also we need to remove one of this actually. Jesus Christ, -1. Oh, that's funny because it's actually the bottom y. Let me see. Bottom y is highest index plus this. Actually, let me see. No, it needs to be 3 free spaces, so then it needs to come. So that 1, 2, 3, and then it needs to clear. Okay, so we don't need to remove this one, -1 here. This will be a fun one. I should probably add some visualization just to make sure. Because I need to know when I need to start testing. But I can just, yeah. So basically I should test once it goes down 3 times. That's basically it. So the bool test is false. Here we do okay, let's see. Let me think, because we spawn it and then we do we do a move or a drop first? I think a move first, right? That's not it. Let me see where my screen is. Is it this one? Yes. Okay. First, yeah, it first moves. Okay. So let's see. Move is yes, for a move, and it's actually x move, and this is an int. So we do x move is move list move index, and we increment that one. mod move list length. We can do that here as well. Const, not just int. Let's move list length like this. So we do if move larger than 0. No, if it's smaller than 0, else. And basically, I can just call this. I could have done this just like true, false. So we can just do bool xmove and call this xmove right. And then we just make the checks even easier. So if we move to the right, make sure check right bounds. Make sure larger than 0. So we do if block pos.x larger than 0, block pos.x. We decrement that one. And let me check if this works, because I don't remember if that actually works correctly. Then we move down. Int move down count is 0, because we only have to test actually after we've moved down 3 times. So here we do if larger than 3, test for collision. Yeah, test for collision. Bool hit is false. If hit, then we do move down count is 0. We reset this. While not hit. False, and then we move on, and then we also update add block points to grid. Sure, yeah, and how do we call it? Block bottom Y, that was that one. So we do, and it's actually oh yeah, sure. Not sure that I need that right now, because we need to know the highest entry in the grid. Do we need that actually? No, we don't, because we figured that out here. Okay, so now we do for each var point in block dot points, and then we do if not, we do grid try get value. No, if not grid dot try get value point dot y out var x points. X points is this grid dot add point dot y comma x points, and then we do x points dot add let's see, and it would be point dot x, yes, like that. So we also need to make sure that this doesn't update, else we do block pos dot y, and we increment that one. Okay. Test for hit. Okay, so this is basically the logic that we need to do there. This shifts the, okay, so if block pos dot x is smaller than and this, let's see, block max x is and then we take block pos dot width. No, it's actually this block dot width plus offset dot not start offset dot x. So we need to take width, area width minus this, and then we subtract one more because it's a zero-based index. Minus 1. Subtract 1 for zero-based index. Okay. So do it like that. That makes this check easier. So if block pos dot x smaller than this, sure, we increment block pos dot x. Now we probably need to check the collision here as well, by the way. And the annoying thing is that we need to check that for the entire move. So we need to yes, because we need to take our desired position. So bool has collision. Let's see. Int x, int y, list int x, int y, points, and then we do hash, no, dictionary, int hash set, int grid. Okay. Bool result is false. Return results, so we satisfy that. Then we go for each var point in points. Let's see. Start pos. Okay, so we do int x and y. We do x. We do y is start point dot y plus point dot y. If grid try get value y out var x points. Otherwise, we don't need to check anything. X is start pos dot x plus point dot x. If x points contains x, the result is through break. Okay, so this one tests if there is a collision. If not, has collision, block pos block dot points grid. Then we increment. Same here. Hit is has collision. Boom, boom. Yeah, basically. We need to do block boss punt. We need to simulate moving down one actually. Block boss.x, block boss.y plus 1. Why is it complaining? Because I have a double thing there, okay. So this should actually work, I think. Let's do this. Let me see what the biggest point is after that. If hit, then we do that. Console.right line max y grid but keys dot max. So let's run this and see what it does. I need to change this to day 17. And I have an infinite loop somewhere probably. Oh yeah, it's actually, I go in the negative space. So let me just check this because it will actually be min times -1. But yeah, because I have my y-axis inverted. Let me see. Haha, move down count is way bigger. So let's see. So yeah, that one has the full floor. But has collision is false, and that is because the Y moved through it. No, it hasn't gone down yet. Oh yeah, this was what I wanted to check. So this one updates, okay, so block pose is 3 now. It resets the block pose. I should not do that. So all of this needs to be outside of this. Let me see. And then we do the move, right? Okay, let me see. Point.y is 0. Let me just run this right now. Move count is 0. Oh wait, I need to do this outside of here. Else, I need to do this as well. Okay, let me do that again. And I need to actually have my logic here. Let me run it here. So now it moved 4 times, so Y should be okay. That's not good. Oh yeah, it's one above, so that is correct. So now it needs to go into it, so that means that this should have a collision, so that is good. So we reset this. Hit is false, okay. But we should also move... no, I don't need to reset it here, actually. Yes, so this one is bad. So let me just set this back to true. And probably the move down count here also needs to... so move down count is 0. So we do this. Okay, let me go back here again. Stop. Run. Okay, so this one is now 4. This one has hit collision, that is good. Then it adds... oh wait. Ah, this is bad because it needs to be offset. So it needs to be block pos.y plus this. Does it need to be plus or no? It needs to be, because this one is at the top, so that is good. Yes. Yes, that this is correct. No, not yield. Come on. And this, so I can just do this and this, and then it's the same int x is block pos of x plus point x, like this. And we should move these ones up here as well, just so that we don't declare them all the time. So we have x, y. Okay, so let's see. I'll just set my breakpoint here. So the y becomes -1. Okay, cool. So now x point is -1, 1. Because apparently Brock was still 1 off, sure. Let's see, what does grid look like now? Grid has 2 rows. This is not good. Oh no, this is good because they have 4, like 1, 2, 3, 4. And that was exactly what happened here, right? The first one, let's go back up. It rests at... oh no, it rests at 2 here, so it has moved. Okay, let me see. Let's just debug this. Block moved 1 to the right. Block pos dot x. Block pos y. Okay, can't move to the right. Do the same here probably. Collision detected. moving one down to. Okay. So let's see what it comes up with here. So we take this one and let's see what our code does. Let's see, moving one down, moving one down. Okay, why does it go down but not to the left? That's weird, wait. Oh, but I also do this one wrong, by the way. Else can't move due to collision. To the right due to collision. Okay, so I can do the same here. And we also need to check I think we can check this, right? If we don't need to care for it if we don't have the move count yet. Okay, so let me run this again. Can't move to the right. Okay, that's not correct because it can move one to the right. So let me check here. Wait. Oh no, it's this one actually. It's not the collision one. So block plus X is 2, max is 7. Wait, what? Let me see, 7 minus 4 and 2. So that would leave me hey, wait, if it starts at that one, it's too much. No. 1, 2. Yes, okay, I need to start at index 2. But it has, how many, let me check this. Yeah, the first rock start, no, that's correct. But it should be able to go up to index 3 there. So it's like, let me see, max X is actually, oh no, it's easier than this because it just needs to be this. This one should be 3, right? Oh no, it's basically just this. Yes, okay, never mind. Okay, so let me check now. Moved one to the right, moving one down, can't go to the right, moving one down, can't go to the right, moving one down, move one to the left. Okay. Collision detected. and it actually tests at, let's do, y is, let me just use this and reuse it here so that I don't have to do that over again. So this is the y that we test. Okay. Boom. Cool. That's not good. Okay, that's not good. Let's see. Let me drink a sip of my cappuccino. Oh, because when I do the other hit detections there, I don't actually add this logic here. Let's see. Let's see. Let's see. Can I do that here actually? I should probably have something to just do this. But yeah. No, that's good. Collision there. Oh, actually that's not true. It only has a collision when it can't go down. This just blocks it. So let me go back. So yeah, let me just walk through it here, just step by step. I should probably also make sure that I check this one. And I shouldn't have to recalculate this every time, but that's okay. Let's see. What is highest index? Okay, so this one is bad. So we do if y is larger than this is y, okay. I think that should also help. Okay. So now this block starts at 4, is that okay? Because the bottom y is 3. Highest index, wait. Didn't this one get updated? Okay, let me just check here. Oh yeah, this is the first time. Okay, let's run this again. So now we have the highest index becomes, it's still 0, that's not good. Let me check here. Oh, we're in negative space. I should probably have just done this differently, but yeah, the highest index is actually the lowest y. So to make this confusing, I'll run this first time, and then we have the highest index is minus y, so that's okay. So the bottom is raised by 1, so that is good. I think this is correct. Let me see. And what is the actual answer that it spits out? 3340. How close is that to the actual answer? Close, but no cigar. Okay, let's see. What are these intervals? Let's see. The next few row begins falling. Okay. So yeah, let's print out the grid. Let's add that and see where we go wrong. So we do void print grid, dictionary int hash set int grid, and do the int min x is min y is grid dot min key. Max y min x is 0, max x is area width. For int y is min y, y smaller than max y, increment y. If grid try get value y out for x is calls else console right line. New string filled area width. Okay, so now we do for int I is int x is min x, x smaller or equal to max x, increment x, console right line, no right. And then we do calls that contains x question filled empty. Okay. Boom, 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 boom. This one needs to be equals, and now we need to do after each one of these we do print grid, grid. Okay. If block index is 10, great. So let's do this. Oh yeah, I need to char on is on, char off is off. It's actually off that I need to print here. Okay. So let's compare. So the first one is correct, right? Now we get the second one. How does it land? We're one off here. Okay, so let's see what it does. New row begins falling. Blocked move on the left. Why? That's weird. Blocked move on the left. Oh no, block moved one to the left. Okay, that is correct. And then it said block moves one to the right. Okay, we have that too. And then it goes one to the left again. Sure, and it goes one down. Jet of gas push one to the right. Oh no, okay, so it was correct. Sorry, I was looking wrong here. This one is correct. And then we get the L. How does the L land? Oh, wait. The L lands here to the left. Ah, the L should fall one further to the left. Okay, let's see. Why don't we have that one? Let's see. Block moved one to the right, one to the left, one to the left, one to the left. Then it's at 0. So why didn't it see a collision here? Because it should not be able to move to the right. Let me see. Yes, we expect this case here. So let's see. This one is block index 0, 1, 2. Okay, let's see. Okay, what is the issue here? Let's run this. Okay. This is the 3 by 3. Yeah, okay, this is the cross. So this one is the next block. This is the L shape. Okay. So, okay, let's see. We have 1 move, 2 moves, 3 moves, 4 moves. What is the block pos X now? Okay, so now it's to the left. Let's see. So, okay, we checked collision here. So this is every point in there. And it's actually the, let's see, which point, it's the last point that should cause the collision here. See, okay, so now we have the X points. And it says it has one at 3. Is that correct? Let me see, because, yes, 0, 1, 2, 3, okay. You know what the issue is? For hit collision detection, it should give the move that it wants to make, not the move that it's actually making. So that is the issue there. So has collision, and this one needs to be block pos dot x plus 1, block pos dot y. Right? Yeah. So the same here. This should become block pos dot x minus 1, comma, block pos dot y. Okay. So far so good. Let's run this again. So now let's see if this shape matches up a bit with what we're seeing here. Yeah, so you can see it definitely moved in there. can't move to the right due to collision. Okay, cool. That is awesome. So does the shape match up? It sure does. Let's see. This one is the same. Okay, it seems to be working now. So okay, let me see if I run this now without this one. And I print the grid at the end. 3086, is that correct? Yes, that is correct. Woo! Nice. Let's see if we can run this against the real input. We should probably disable all of this test printing here. Bool debug print is false. So let's do this. Okay. So we do input 3124. Okay. Not the right answer. The answer is damn it. That's not good. Curiously, it's the right answer for somebody else. What? Okay, that's weird. Let me see. How is that possible? Let me just test this. Ah, okay. So with getting the input, there might be like a character in the end. Wow. Trim. Okay, so there's a new line in the end that messes this up. Okay. I was like, what? It's really funny though that with the new line, it has an answer for somebody else. And now I probably need to wait. Woohoo! Gold star! Yay! Okay. The first half of this puzzle is complete. It provides a gold star. Yeah, thank you. Part 2. The elephants are not impressed by your simulation. They demand to know how tall the tower will be after that many rocks have stopped. Only then will they feel confident enough to proceed through the cave. Okay. It would be this tall. Okay. Okay. So is this another case of just getting the input length times the shape length and then see when it repeats? Because after that you have a repeating scenario, right? Where just you get into a situation where you already were before. Okay. So that's a million, billion, trillion. Okay. It doesn't even fit into a Okay, let me see. Yes, okay. Let me see, because what I'm thinking is that we need to do move list dot length times block. Let me see, console dot right line move list dot count dot length. Okay, so that's an odd number, but if we do, let's see, this times block shapes shape count, right? Long check is this, percent repeat after. Let me just check this. So basically, what we could do is int let's see, because I'm just curious to see how the next step would result after the state of the first one, so we can chunk that, and if we know that, if that changes the next set of results, I'm really curious to see. So let's say if we do last block is repeat after times 2 or times 3. And then we should check like a we should see min y cap basically, if we do it like this, and I do it like this, then grid, comma, min y, min x, max x, min y, max y. Basically, I can try we don't care about this one actually. We can do print grid, and then I do 0, area width -1, and then we do check. No, what was the number again? Repeat after actually. So we do repeat after in the negative -10 +10. Why doesn't it like this? Oh, because this needs to be an int. Okay, fine. Something like this. Okay, I shall need some time to figure this out. Because basically we need to find a pattern that forms and see if we can divide the space there. So yeah, I will have to do this later because I have other stuff that I need to do now. The groceries are getting delivered in a bit and we need to go out with the family. So yeah, I'm happy to have solved part 1. I will dive further into part 2. But basically what should happen is after a certain amount of numbers, the blocks and instructions align again. So you have the same kind of things happening, but the starting condition is different because you start with the floor and after you run you have a different end there. So you might need to run twice, then take that because then it should be stable, I think, and then run it again. But it might also just offset every time. So I shall need to take a look into that and see if there's a way to spot the repeat. But it has something to do with this like move list and the actual moves and finding a stable recurring pattern. So yeah, maybe I can just scan like the entire thing to see if there's a repeating part that we can skip. Something like that. There's probably a way to figure this out. I don't know it right now and I don't have time to implement it, but I will see if I have some time to do a part 2 later and get back to you. So I'll either stream that or I'll include it in tomorrow's stream. So yeah, thanks for keeping me company. I enjoyed this one. I've never written Tetris before. Now I can say that I have because this is basically the Tetris logic and then you need to add some logic for clearing, but yeah, that was fun. Have a good one and see you tomorrow or maybe tonight. Bye bye.